Good afternoon, everyone. So, let us see what you can see my screen, right? Or no?
Yes, ma'am.
Yeah. So, yesterday we were actually discussing about the fuzzy membership functions. So, how many fuzzy membership functions we discuss? Can you list the fuzzy membership functions that we discussed?
Triangular, increasing, decreasing,
Increasing, decreasing, triangular,
trapezoidal,
trapezoidal,
Gaussian, Cauchy, and sigmoidal.
right? So, these are the standard membership functions. Using this, you can represent any kind of fuzzy set in a particular domain. Okay. Apart from this, we also introduce the concept of fuzzy relations. What is a fuzzy relation? Fuzzy relation is a n-dimensional fuzzy set. In particular, we looked at binary fuzzy relation, right? We looked at binary fuzzy relations, that is, or 2D fuzzy relations, but 2D fuzzy sets. Okay. So 2D fuzzy sets, basically, how do you form? So one way of doing it is using Cartesian products. So you have two fuzzy sets which are there, and from those two fuzzy sets, you are combining them to find out the Cartesian product. Okay, and the other way is you are given with universes of discourse, U and V. Okay, you are given with universes of discourse U and V, and you have to write a relation which will establish some relationship between the elements of U and V. Okay, so for example, we saw x is approximately equal to y. And the standard way of writing it, the usual way of writing it is you use a table. So here all u values, here all v values, right? And here you will have the membership values. You also saw the notations. Okay, in general, if you want to write using ordered pair notation, you can write it in that fashion as well. But the way to write it is membership you will have on top. So this particular value, suppose it is 0.5. So that membership will be on top, and then suppose this is 1 and this is 1. So suppose this is A. So 1 comma A will come here, right? U comma B. So the membership is for the relation between A and 1 and A. Okay. So this was what we discussed about fuzzy relations. So today what we will do is we will look at some operations on fuzzy relations, the properties of fuzzy relations, fuzzy composition, and some problems on these concepts. So there are four types of operations which can be performed on fuzzy relations. The first one is union, then intersection, projection, and cylindrical extension. So these are the four operations. Let us look at the formulae one by one. First is you have to find the union of two fuzzy relations, R and S. Okay, so it's similar to what you have done with 1D fuzzy sets. It's the same only. So it's simply max operation. So you find the max membership, whichever is the max membership of the two, you have that in union. Okay, so max, so it's basically you have two relations, R and S, so two tables, right? This is R, this is S, right? So what will be union? What is important here is both R and S, this is R, this is S, both R and S should be having the same dimensions. Okay, both R and S should have the same dimensions. So both have to be X cross Y. Both have to have the elements from X and Y. Okay, so to find the union, it is simply, so if this is some membership here and there is some membership here, for these two elements, whichever is the max, that will be in the resultant, in the union. This is R union S. So in R union S, you will have max of this and this, right? Likewise, for all the pairs, you will have the max value taken and put into this. So that will be the result of union of two fuzzy relations.
Ma'am, the elements can be different.
No, the elements have to be same. They have to be drawn from the same. It has to be X cross Y only.
No, ma'am, but I mean from X cross Y, can the elements drawn be different or they have to be same? Like X1, X2, X3 and Y1, Y2, Y3, say for R. Do they have to be same for S as well, or S can have X2, X3 and X4?
They have to be same.
Same, okay.
Yes. Next is R intersection. So intersection is the min operation. Same table, only thing instead of max, you have to take the min. Okay. Next, so this is an example. So you can find this out. What is R union S and R intersection S? Okay. So R union S will be the max operation, right? So for this, it will be 0.4. Whatever is in this particular color, brown color, that is the union values, right? The maximum. Right? And whatever is the minimum, whatever is remaining, that is the intersection, right? So that is how you find union and intersection of two fuzzy relations. Now, next is projection. So projection is a different kind of an operation. It basically reduces a relation to a lower dimension, to a smaller dimension. Okay, so if you have a ternary relation, three-dimensional relation, right? If you apply projection operation, you can reduce it to a binary relation. And if you have a binary relation, you can reduce it to a fuzzy set. If there is a fuzzy set, you can reduce it to a crisp set. Okay. In fact, it will be a single crisp value. So projection is one such operation. So how do you actually perform this operation? So if this is a relation given to you, consider this as a relation given to you R on the universe X cross Y. So this particular relation will actually what you have to do is you are going to reduce the dimensionality. Projection is an operation is going to reduce the dimensionality. Okay, so from this relation it will reduce to a fuzzy set, 1D fuzzy set, right? So projection can be performed on either X or on Y. So the projection can be on X or on Y. So if you want to perform projection on X, then what you have to do is you will get a fuzzy set in X. You will get a fuzzy set in domain X. Projection on X on of for this relation, that means projection of R on X is a fuzzy set such that its universe is X. So all the values from X you will have. Okay. So how will you perform? You look at this particular column. Okay. Sorry, this particular row. Okay, and whatever is the value, maximum value, that will be assigned to X1. The membership value of X1 in the fuzzy set that is created out of this projection. So it will be something like this. The membership value which is actually associated with the element X1 will be the maximum of all these Y values. Max Y, you just project it or put it along with X1. Okay, so this will be 1 over X1. Similarly, whatever is second row, you look at the second row, whatever is the maximum value, that will come with X2. And finally, for X3 again, whichever is the max value, that is this, will come with X3. Okay, so this is the projection operation, right? If you want to find projection on Y, the same operation, so you will get a fuzzy set in Y. You will get a fuzzy set in universe Y. And what will be the values? You have to perform the same operation now column wise, right? So for this particular column, whatever is the maximum value, that will come with Y1. Are you getting it? Whatever is the maximum value out of these three values will come with Y1. Whatever is the maximum value will come with Y2, Y3, and Y4, right? Is this clear? The definition of projection. How do you perform the operation? So if you have a binary relation, it will reduce to a fuzzy set. Okay. So if you are reducing it, your projection will be on X or it will be on Y. Okay. On one dimension X, on the other dimension Y. And you have to take the max row wise or column wise. Okay. So that is about projection. The opposite of this operation is called as cylindrical extension. So what it does is it converts a fuzzy set to a relation. It converts a fuzzy set to a fuzzy relation. Okay. So if this is the fuzzy set that we are considering, and we are applying, so A is the fuzzy set that we obtained earlier from the projection operation earlier. Okay. So if we apply the cylindrical extension, then what happens is you can extend this to the domain Y. Okay. So cylindrical extension of A will be, so whichever is this domain, so domain is X, you can extend it to another dimension, that is Y, the second dimension, that is Y. So what you will do is you will simply replicate the values. You will simply replicate the values along that dimension. So you have 1, 0.8 and 1, and you have to perform cylindrical extension on the domain X cross Y. So you have to go from this fuzzy set, which is 1D, to a 2D fuzzy set, that is X cross Y. Okay. So you simply replicate this, or you extend this particular value along the Y-axis. Okay. So 1 has to be replicated so many times, and whatever the values are, they have to be replicated. So that this particular operation is called as cylindrical extension. Okay. So if this is the fuzzy set, what is the cylindrical extension of this? Cylindrical extension of B on X cross Y will be what? So this is Y. Y, this was X. So it is 0.9, 0.8, 0.7, and 0.8. Right? Simply extend it along the x-axis. Right? So this is the cylindrical extension of B. Are you getting this?
Ma'am, can you go back to previous slide once?
Yes.
Ma'am, here also it's a projection of R on X, and on next slide also it's projection of R on X. So it should be Y.
R on Y. So it's a typo.
Ma'am, in this case, we know that it's the projection of R. So we replicated the columns thrice. But in case we are not given R at first, how do we know how many times we have to replicate?
Yeah, so that will be given to you. Na? So Y will contain Y1, Y2, Y3. That will be given to you.
Okay, okay.
What are the elements? Yes.
Okay.
So let us take this problem. So this is projection on X. You have to find out projection on Y and the cylindrical extensions of the projections. Okay. Such kind of problems can be given, or if it is directly talking about cylindrical extension of a fuzzy set, then you will be given the elements. Can you quickly tell me what is the projection on X? Projection on X means what will you have? Which kind of fuzzy set? Which universe? On X.
One, one,
X.
one.
X. Projection on X means X. Remember it that way. Projection on X means you will have all X elements. Projection on Y means you will have all Y elements in your fuzzy set. Okay. So of course you are going to take the max row wise, right? It's 1, 1, 1. Fine. And what about projection on Y? It is column wise. Okay. So whatever is the max value in the row, in the column, that will be associated with Y. So this. So I think this is very simple actually how to perform these operations. Okay. Not this, huh? It is 1 and 1. Okay. Cylindrical extensions, whatever relation you get, you just have to extend it along the other axis. That's it. Okay. That is how you do it. Next is properties of fuzzy relations. They are similar only to your properties of fuzzy sets because fuzzy relation is also a fuzzy set. They're similar only. So I'm not discussing that. You can go through it. Next is fuzzy composition. Fuzzy composition is basically, again, you want to combine two fuzzy relations where the relations belong to different product spaces or different universes. So one relation is on x cross y and the other is on y cross z. Then you can perform this fuzzy composition operation. So it is important that like your matrix multiplication, you recollect what is the condition for multiplying two matrices. The same condition applies here. The dimension of the columns of the first matrix should be equal to the number of rows of the second matrix. Then only you can multiply the two matrices. Similarly, here in composition, if the same condition will hold. So one fuzzy relation is on x cross y, the other is on y cross z. Then you can perform fuzzy composition. So there are two main compositions which are used. One is max min and the other is max product. Okay. So the max min composition basically is going to have it's basically performing matrix multiplication. I mean, the operation is similar to performing matrix multiplication, but the what you're doing as part of it is different. So max, you're first finding the min and then you're taking the max of it. That is max min composition. You're finding the product. I can say this is somewhat similar to very, very close to matrix multiplication. So what you do in matrix multiplication is you do a row. So if this is one matrix, this is another matrix. You look at this row and this column, first row, first column, right? You multiply the individual elements. You multiply the individual elements, right? You multiply this with this with this with this, and this with this. And then you sum them up, right? So it is a sum of products. So here what you do is you multiply the corresponding elements. So first row and first column. And then what you do is you apply the max operation. So rather than applying addition, you apply the max operation. So it is max product. So by this same idea, you can guess what is max min. What will be max min? Instead of multiplying the two values, so this value and this value you are multiplying, right? This particular value and this particular value you are multiplying. Instead of multiplying, finding the product, what you should do is you should take the min of the two values. You find out the min of the two values, and then you will, what you will do similarly for these two also. Whichever is the min, find out these two. Whichever is the min, find out. So you'll get four different values, right? So out of those four different values, find out which is the max value. That is max min. Okay, so that product is replaced with min. So these are the two ways in which you can compose two fuzzy relations. You can combine them using fuzzy composition. Okay. Formally, the definitions are given here. So max min is mathematically stated here. So if you're asked to write the definition of max min, then in that case, what you have to do is you have to write the formal definition in this fashion. So formal definition is just writing it mathematically. So min of. So you have two fuzzy relations, R1 and R2. R1 is defined on X cross Y. R2 is defined on Y cross Z. Then what is max min composition? You just take min of XY and YZ. XY is from R1 and YZ, this pair is from R2. So the membership values of these two pairs, you compare, find out the min, okay, and then you will get a set of such values. So from these set of values, you find out which is the max. And that will be the value for xz, like your matrix multiplication. What is the result of matrix multiplication? It's a matrix whose dimension is x cross z. Similarly, here the result is a relation whose dimension is x cross z. Okay, so R1, the notation is O, small o, R1, O, R2, that is composition. This operation, this O means composition. Okay, so this is the mathematical way of writing it. Okay, or some alternate way is also given. You can write it in this fashion also. Okay. Similarly, for max product. Max product is, instead of min operation, we are just replacing it with product. Okay. So the same idea, only thing is you have this as product, rest all remains same. So mathematically, you should be able to write it, max min and max product. Okay. So given these two relations to you, R1 and R2, so you have to find out R1 or R2 using max min and max product composition. Okay, so how will you do it? Matrix multiplication, right? This is, what is the dimension of this? 3 cross 4. What is the dimension of this? So what is the result of dimension? What is the resultant of dimension R1? What is the dimensions of, sorry, what is the dimensions of the resultant?
3 cross 2.
3 cross 2, right? So max min first, quickly, max min. So this is the row, right? This column, which is the max. 0.1, 0.2, 0.5. Sorry, you have to take out the min, right? So 0.1, I'll just write it here. 0.1, then 0.2, then 0.3, and then 0.5, right? These are the min values. First, apply the min operation, right? This row and this column, apply the min operation for the corresponding elements, right? If this is xy, this is xy, this is yz, yes or no? This element is xy, each of these elements xy, this is yz. So you apply the min operation for the corresponding elements. Once you do this, find out which is the max. Which is the max? Is 0.5. Write 0.5 here. Okay. Similarly, find out this. For finding this, you will take the which row and which column? First row and second column. First row and second column, right? So min of this and this is 0.1. Then you have 0.2, 0.3, 0.3. So the answer is 0.3. Is this clear? Is this clear?
Yes.
What about this? Again, same operations you can perform and complete this matrix. This is about max min. What about max product? Replace min operation with product. 0.1 multiplied by 0.1. It is 0.01. 0.2 multiplied by 0.2. 0.04. 0.3 multiplied by 0.5. 0.15. 0.5 multiplied by 0.7. 0.35. Right? Which is the max? 0.35. Okay. So is this clear? Max min and max product.
Yes, ma'am.
Now, for this particular problem, can you give me the matrix for max min and max product quickly? All of you solve and tell me. Just go through the problem statement. Yes, you have found out what is the max min composition. So relation R and S is given to you. This is R and this is S, right? Relationship between color and grade, maturity. What is the dimension of this? X cross. Each of these is 3 by 3 and 3 by 3. But this is X cross Y, right? This X and Y is given. X, Y, Z is given, right? And this is Y cross Z, right? So the resultant composition of these two relationships will be X cross Z. So it will be the relationship between color of the fruit and what?
Taste.
The taste of the fruit. How does the color correspond to the taste, right? So this is some real world example given to you. So this is a relationship between color and the grade of the fruit, or the maturity, grade of maturity. And this is between grade of maturity and the taste. So if you want to find out what is the relationship between the color and the taste, then you apply composition operation to combine them. So now simple max min, just have to, this is, in fact these relationships are very small. Tell me what is the values that you have got. Let us verify. Tell me what values you have got for as part of max min. Can anyone tell me?
1.5.3 first row.
1,
0.5.3.
0.5.3. Next,
0.7, 1.4.
then
0.211.
can anyone verify it for me? Is it correct? Okay, this one.
I think third row, second column should be zero point 0.7.
Yeah, so I think here, Harsh, you have mistaken. This is second row and second column. No? So you find out the mean values. You must have taken max by mistake here, right? So mean is 0, 0.2, and then 0.7 mean value, right? 0.7. So this has to be 0.7 max of all these mean values. That is 0.7. Okay, so you have chances of making mistakes here. Be careful. Just take some extra time and write the answer so you'll not make a mistake. In a hurry we can make a mistake here. So sometimes instead of mean, we have the tendency to pick up the max value. We make a mistake while solving these problems. Okay, and that could result in the entire question this being wrong. Okay? And what I suggest, if this is asked as such as part of problem solving, then you should write the formula. You should write the mathematical formula for each of these compositions. You should also show one or two computations by hand, rather than all, not all, but at least one and two for each by hand, how you have arrived at this particular value. Let's say this value, the first value here and the first value. While solving, you have to do that as part of your theory, uh, right answer, question answers. Okay. Similarly, here you have to take products. So what do you get here? First value. So next time what we will do is, we will whatever we have studied so far, let us test ourselves. Let us have a quiz at the beginning of the lecture, because lots of formulae and properties and operations have been covered. So let us again have a test next time. I mean, which it is not graded as such, just to understand our knowledge. Okay, let us discuss some questions where we test our reasoning. Okay. So next lecture, at the beginning of the lecture, we'll discuss that. So here quickly, I want someone to answer, please. So this row and this column, you have to find out the products. Can find the max. It will be 1, right? Can someone volunteer?
Yes, ma'am, it's 1.5.15. 0.7, 1.3.
Point 3,
0.4.
0.4 Harsh.
Second,
Next,
0.14.
hmm.
0.71.
Hmm.
No, not 0.71. It's 0.7 and 1
Yes,
for the
point
next
7.
cell.
Hmm. Okay. So this is about composition operation. There is one problem that I am giving to you for practice as homework. So this is a scenario given to you. You perform. In fact, what happens in this problem is, you are given fuzzy sets. The fuzzy sets are given to you. You have to form the relations, and then after you form the relations from these fuzzy sets, you have to form relations, fuzzy relations. It's simple only. Only thing is, the relation is not given to you directly. The fuzzy sets are given to you. Okay. Form the fuzzy sets R and S. Okay, and then apply composition, max min and max product. Okay. So try this problem. I want the answer next time. Next time, let us revise the concepts in the form of problem solving, more problem solving, where we'll try to reason things. If we have not understood clearly, we'll revise it. Okay, next week. So next week, Monday, I have kept a lecture at 12:15. Fine. So I'll stop now for today.